Sanjay Jaiswal, Managing Director of Aerox Technologies Private Limited, Aurangabad. His topic is Managing Medical Oxygen in the Hospital, Past, Present and Future Perspective. Come on everyone, can we have a louder applause and louder noise for him?
Okay, so this pandemic went on, and the most talked subject was oxygen. Not only India, the whole world was, running behind oxygen. And somehow, in the morning session we discussed, we were not so much prepared. Country was not so much prepared in hospital infrastructure, including oxygen. But somehow, in 2011 we started this, we bought this technology in the country with a lot of R&D. And from 2011 to 2019-20, we were able to install around 550 systems, which was producing around 400 metric ton of medical oxygen. So if we have not started this business, then we have been short by 400 metric ton of medical oxygen in the country. And just see what would have been the situation where all the media was running behind one tanker, like this tanker is going in the left and right, and his hospital, Bhati hospital, is not reaching, and so that kind of scene was there. So I think we made a major role, we played a major role in building the hospital infrastructure in the country. So talking about general hospital where oxygen is being used. Oxygen is being used in, I don't need to tell you the details, like it's in beds, operation theaters, ICUs, ventilators mostly. Ventilator takes maximum oxygen in the complete hospital. Why oxygen is so important for the owner or a consultant also? Because if you talk about working capital, that's a third major component after salary and your electricity. And that's where your major outflow goes, expenses. So, if it's a new project or generally how oxygen consumption has been calculated, if it is an oxygen bed, then you generally require 3 to 5 LPM. If it is a ventilator, then you require 12 to 18 liter per minute, that's LPM. But when you are choosing a ventilator, just see what is their bias flow. Bias flow is what? It is an extra flow. Beside your weight and age of the patient, it's an extra flow which is given to the patient to detect whether that patient is doing any effort or not. So always you choose a better, because good quality, but if you want a less oxygen consumption in your hospital, then the bias flow of that ventilator should be less. It should be around 2 to 3 LPM, but few ventilators, their bias flow goes around 10 12 LPM. So 10 LPM means 2 D-type jumbo cylinder every day. Then your anesthesia machine takes around 20 to 25 LPM. So, and when we talk about one D-type cylinder, that is 7 meter cube, 7,000 liters. Now, if we take the same combination in old hospitals, the consumption could be more than what I have mentioned here. Why? Because MGPS line, it has to be done by a good brand player. And the servicing has to be done on time to time. Because if you don't service the O-ring, then it starts leaking the oxygen and your oxygen consumption goes up. We have seen a hospital where the consumption should have been around 70 or 80 cylinders, but they were consuming around 130 and 140, and they were helpless. Because your MGPS lines to be of a good quality. So, what are the sources of oxygen supply? As you know, cylinders are very common, and we have portable liquid container, that is PLC, that varies from 150 liter to 450 liter. Then we have a liquid medical oxygen, which is very popular. Then we have PSA oxygen generators. Then the next is you can have a combination of PSA with LMO or PSA with cylinders or PSA with PLC. Now, if you are coming with 0 to 40 grade hospital, then you can have a cylinder and PSA combination. Either of these two, I mean. But if you are consuming less than 5 cylinders a day, it is better to go with cylinders because PSA is not viable in that case. For 40 to 150 bedded hospital, generally you can have cylinder or PSA or portable liquid container or porta cry also. And 150 bedded plus, you should have LMO or PSA. Cylinders can be used, but depending on the availability and the location of the hospital. And you can use combination of PSA LMO also. So what are the parameters you should look what to install in the hospital? First of all, the location of the hospital. If it is in the heart of the city where oxygen is amply good, availability is too good, then you can go ahead with liquid oxygen or cylinders where oxygen availability is good. But if you go a little far, like this liquid oxygen is manufactured at particular location in the country, that location and your hospital location, say 200, 250 kilometers away, then your transportation costs, availability, everything becomes challenging. So in that scenario, we can choose some other source of supply. Also, what are the cylinder rates, what are the liquid rate, PSA, if you are doing PSA then electricity rates, that need to be checked in your particular area. So, what are the, you see the cylinders here. The 5 cylinders here, 5 cylinders, and there is a control panel in between. Control panel shows what is the pressure inside the cylinder and what the pressure line is going on. So, what is the benefit of cylinders? Low investment, less area is required, power source is not required. There are benefits of the cylinders. And if you talk about what are the disadvantages, then it's at 150 bar, so you know how hazardous is that. Then you never know what is the filling capacity you are getting in the hospital. Many times what happens, when you are changing the cylinders, you cannot empty complete oxygen. You cannot take out complete oxygen from the cylinder. Like when you are removing it, you just see you get the voice. That kind of voice is there. It means some gas, around 4 to 5% gas is always there in the cylinder, you cannot take out. Same like your home LPG. Just usko ulta kar do, you can use it for 2-3 days. Another problem is your manpower. You require continuous manpower to operate that in 3 shifts. Then your manpower, the logistic supply, the manifold guy gets friendlier with the supplier, and what happens? 5 filled cylinder goes back. Out of 50 you are using in a day, you never know, you cannot control all that things. 5 empty cylinder can come out of 50. So all that manual things you cannot control. Here, when we are talking about such a big modern hospitals, then we should have some automation, automated related things, not manpower dependent things. Then price fluctuation is again an issue. Every year the price is going up. It's correct also because inflation is there. We used to get cylinders at 120, 130. Now we are getting cylinders at 250, depending on the location. It is varying. And the supplier, oxygen is a drug, we know that. And the supplier must have FDA license to supply cylinders in the oxygen, oxygen cylinders in the hospital. So we need to check from the suppliers where we are getting whether he is having FDA license or not. Now, what? Yes, so when we talk about leakages, just a minute. If you want 7 meter cube capacity of the cylinder, then it has to be 150 bar. But your 95% market is with the local suppliers. Only 5 to 10% is with the branded players. Branded players generally they are giving proper pressure. But normally, if just check in your hospital, what is the filled capacity of your cylinder? If it is 135 bar, then you are getting 10% less. If it is 120 bar, then you are getting almost 20% less. It means, suppose if you are spending 20 lakhs per annum on oxygen, then 4 lakh you are giving for nothing. So, whosoever is your supplier, just check what pressure you are getting. Now, again, the storage of the cylinders, you cannot store more than 200 cylinders in your hospital because that comes under peso then. The height of the manifold area where you are going to load the oxygen, it has to be 4 feet above the ground. Why? Because when your truck comes, it should be just, it should not be put down. It should be just over. So what happens if these oxygen cylinders are not tested with the walls are not tested properly, and if you just put it down on the ground, then a lot of accidents happen. So it is better to keep it at 4 feet above level. The wall thickness should be around 9 feet. If whenever the accident happens of one cylinder, it blows up the complete building. I mean, we have seen the factories of 2 storage has blown up. So if it is a 9-inch, then it can, there only it can be stopped. Liquid oxygen has this tank has 10 micron of protection layer of vessel, and it has a static evaporation of 0.5 to 1%. That is okay also. 0.5% static evaporation. Why? Because liquid oxygen is minus 183 degrees Celsius. And what temperature we require? We require room temperature. It is in liquid form, minus 183. The moment it starts coming down, it starts getting in vaporization form. Now, the vaporizer, when you are designing a liquid oxygen, the vaporizer should be, what is vaporizer? After liquid oxygen, the conversion from liquid to gas is done by vaporizer. The vaporizer should be rightly sized. Like for 6 kL, you are supposed designing a 6 kL equivalent vaporizer. But suddenly what happens, the filling is done once in a 5 days, once in a 7 days. But suddenly what happens in COVID-like situation, suddenly your consumption goes up and you end up taking 6 kL related liquid just in 1 day or 2 days instead of 7 days, that is not designed. So that time it may get freeze, the wall may get frozen, or the leakage may happen. We have seen what happened in Nasik, where 22 patients died because of these kind of issues. Oxygen is stored in a vacuum insulated vessel, and there is to safety, pressure relief valve is there. Now, what does this pressure relief valve do? It is just for safety, it should not go very high, it should not get much pressurized and accident should not happen. So when these tanks get older, their liquid, they starts getting evaporated a little bit. I mean, from minus 183 to when it is coming down, it starts making vapor, and the pressure release valve gets opened, and that is a good amount of leakage. So in your hospital, you just check how many times that pressure relief valve is getting open. So more time it is getting open, it means there is a quality issue and you are losing more oxygen. And we are taking considering liquid at minus 183, whereas all billings are done as per 27 degrees Celsius. So that is again. Then we have this PLC or quota cryo. Initial investment is low, but it requires lesser space, not like NMO. What are the disadvantages? It has a very high, losses. There is a huge 50 to 20% heat evaporation losses are there. So it is better to install a proper LMO instead of having this. Cylinders are also better. PSA is far better. Because in cylinder also you will not have more than 4 to 5% of leakages. Wherein this PLC, the leakages are 15 to 20%. Logistic issue there. Okay, about PSA, generally I will explain PSA in 3-4 lines. This screw compressor which takes air from the atmosphere that compresses it. The compressed air is purified through dryers and filters. Air goes to this generator which has a sieve which separates oxygen from other gas, and the oxygen goes to a receiver tank which is connected to your hospital pipeline. So it works on and off depending on your demand. And the area required is say 150 LPM or 150 square feet, and it can be I think 30% of the PSA are installed on the terrace. You can install on the backside also, wherever you have the option, because it is not under PSO regulations. The area should be protected from sun and rain, and it should be well ventilated. What are the advantages? This makes hospital self-sufficient on oxygen. It's most economical oxygen than compared to cylinders or liquid oxygen. No wastage of oxygen, since whatever you are producing, you are taking that only. It's a clean energy. Your drug and these are not coming in the hospital area. And there are multiple problems, like when you don't know about cylinder filling capacity compared to cylinders, when you are comparing that with the PSA, then doing this billing regularly, manpower, their salaries, all that issues are not there. It's completely automated system. What are the disadvantages? It has a high initial cost. It requires space, but you can use the terrace or whichever the area which is not of that great use to the hospital. Some PSAs are not reliable, so choosing the right company is very important in PSA. Oxygen purity is 93 plus minus 3%. Now, when we talk about this purity issue, this purity is been approved by US Pharmacopoeia, European Pharmacopoeia, and Indian Pharmacopoeia. When Indian Health Ministry also approved that. And when we talk about these pharmacopoeia and ministries giving approval, they do give approval after a lot of studies and research. Very important thing is you have to watch what are the impurities of the oxygen which you are getting in the hospital. The Indian Pharmacopoeia and Indian Health Ministry has set certain standards that carbon dioxide should be less than 300 ppm, carbon monoxide should be less than 5 ppm. Sulfur dioxide, oil content, water content, all these parameters are there. And if you are using it in hospital, you should do a lab test also of your oxygen. This same standard is there for liquid oxygen and cylinders also. So these impurities should not be more. What happened, we have seen in there are some direct test kit and some you can do online also. Most of the time the carbon monoxide level are far much higher. 200 ppm, 300 ppm, carbon monoxide, I'm not talking carbon dioxide. So if your carbon monoxide level is so high, then you are giving oxygen to the patient, the O2 saturation doesn't go up. Because carbon monoxide gets attached to the hemoglobin. And hemoglobin is only carrying the oxygen in the complete body. Now, PSA oxygen generator has got bad names, especially after COVID wave 2. Many hospitals have installed these PSA generators. We know what was the situation. In fact, we were talking about government procurement in the morning session, how public hospitals have been handled and all. So, government was under huge panic and they floated a tender. Initial tenders were good, but when the COVID wave 2 came, they just desperately wanted the things and they have not checked the quality standards. Private hospitals also done the same mistake. Now they have procured these PSAs just without, they are not looking at US FDA, they are not looking at CE medical devices class 2 certification. So what happened? All bad PSA generator got installed. Now in PSA, you really require technology of flow. Everybody was talking about sieves, but nobody was talking. We are expert in this. So flow of internal flow. Internal flow is how much gas should go in, how much equalization should happen, how much outflow should happen. That is a flow. That gives a sieves life. When in say aerob generator we say 20 years kind of sieves life, whereas in other generators the sieves life is 3 months, 4 months, 6 months, maximum 1 year. It's gone. And sieves is almost 25 to 30% of your equipment cost. So how will you do the maintenance and all? If you are taking CMC contracts, say 6%, 7% of your equipment value, that is the industry standard. And sieves only costing around 30 to 35%. What will happen? The person who has sold you will never turn up. That's what happened with the government, and that's what happened with private hospital. So that is the reason, many PSA stopped working. So what we should do? They should have seen at least, the companies who have the track record of 5 years. At least they should have considered that. But government hasn't considered that, and few private hospitals also haven't considered that. Every year, what is also the same 11 kW compressor, same electricity, the production capacity with the few local manufacturers or other manufacturers are say 100 LPM, whereas if you have a good quality generator, then it was giving 150 LPM. So checking electricity to produce this much of LPM, it's also important. Also, the sizing of the generator has to be done properly. What happened? Government has installed 500 LPM, 1000 LPM to the hospital, where the consumption, they have installed 1000 LPM to the hospital where the consumption is 100 LPM. So if you are having 100 LPM consumption and if you are given 1000 LPM, it's not going to work. It has to be sized properly because 1000 LPM will have, if you are going for a non-branded kind of generator, then it will take 90 kW electricity, and that is going to that's not going to work. And hospital is not using that. That is the main reason. Okay, and last few slides. Seeds quality need to be monitored. That's correct. And how to choose the right brand? And it's very simple. Take 5 years experience. They should have US HPIE, European C Class 2B certifications. Then if you have to have a standby compressor if you are consuming 100 cylinders or 1 metric ton kind of oxygen to take care of redundancy. Then if consumption is say 3 metric ton, you should divide it 1.5, 1.5, 1.5. 3 systems should be installed. That's how major international installation is being done. And I'll always take peak consumption in the competition. So this is international installations. When I told you the requirement is for say 2 systems, take 3rd system as a standby if you are having a very big hospital. This is installed in 1997, almost 26 years of working has been done. These are international installations. This is in China. This is again in China. This is where I have taken the photo. In the morning we were talking about public hospitals. This is government hospital, 24-story hospital, and 1,800 bedded hospital. See how well they maintain it. And just a cost comparison, if you are taking 110 cylinder a day, then you end up spending around 1 crore rupees in a year. If you are using liquid, then you end up spending around 67.5 lakh in a year. And if you use a good branded generator, then you end up spending 28 lakh rupees. So 1 crore, 67 lakh, 28 lakh. That is the costing. So you have to choose. You can have the combination also, liquid and PSA combination. If you do liquid and PSA combination, your cost comes down. Existing hospital, you can do that. Same thing, the only one parameter is there. The PSA pressure should be set at 4.5 bar and liquid pressure should be set at 4.2 bar. The same combination of liquid and PSA is done in Asian Hospital, Hyderabad, Choitra, Indore, Aurobindo, Indore, Safdarjung in Delhi, LNJP, RML, Trishul Medical College, Gangaram City Hospital. Their combination has been done and they say, overall, Aerox has 900 installations in the country. Major is in Maharashtra, Uttar Pradesh, and Gujarat. Adani Group, Meenakshi Mission. As per CRISIL has just published a report. Aerox is having 55% market share in the private hospital. And they are saying there are 1,09,000 hospitals. Out of that, only 4,000 hospitals have installed PSA. These are the corporates who are using this system. Adani, Birla, Teams, Apollo Spectra, Tata Memorial, Bajaj. These are the people who are giving regular, orders to. India is one of our customers. UNICEF, CMSS. Thank you.